Medicine historically treated the human body like a standardized machine, assuming treatments and risk factors apply to almost everyone the same way. Yet we often see a paradox. Two patients can follow identical diets, workouts, and medication schedules, but one thrives while the other falls ill. Sudden cardiac arrest kills over 400,000 Americans every year, with a survival rate of only 10%. It frequently strikes people who show no traditional medical risk factors. Surviving these threats requires us to look past average demographics and decode the highly individualized biological signals happening beneath our skin. Our hearts act as vast electrical transmitters, outputting localized data more complex than a simple pulse. Researchers at UW-Medicine and other institutions have developed AI models designed to scrutinize electronic health records alongside electrocardiogram data. The AI detects subtle anomalies in these electrical patterns that human doctors might miss, allowing it to predict cardiac arrest months before it happens. This technology creates a significant jump in resolution. Older models were broad, typically flagging 1 in 1,000 people. The AI refines that prediction to an actionable 1 in 100. This foresight allows providers to make timely interventions long before a physical symptom appears. Every patient generates a unique electrical signature. Decoding these patterns suggests that cardiovascular risk is far more specific to the individual than standard profiles can capture. Beyond our own organs, much of what makes your biology unique isn't even human. You carry a second genome in your gastrointestinal tract. This gut microbiome is an ecosystem of trillions of bacteria, fungi, and viruses operating in symbiosis. This illustrates the gut-brain axis. These microbes maintain the intestinal barrier and produce compounds that modulate your mood and immune system through constant chemical communication. When this internal ecosystem falls into an imbalance, called dysbiosis, it can silently trigger chronic inflammation and gastrointestinal disorders. Physical resilience is a joint effort between our human cells and this highly individualized, ever-shifting microbial ecosystem. This unique bacterial cohort governs how your body reacts to the outside world, specifically when processing pharmaceutical drugs or cannabis. Scientists are finding that a standard dose of THC doesn't really exist because our internal processing networks differ so wildly. Specific gut microbes actively metabolize THC. These bacteria can break the drug down into psychoactive or inactive components before it even fully enters your system. This microbial crosstalk intacts your endocannabinoid tone, which helps regulate the brain's systemic response to the substance. When we consume a drug, we are feeding it to our unique microbial filter first, which independently alters its impact on our minds. From the gut, we move to the liver, where your genetic code further individualizes how you process chemical inputs. The liver uses specific enzymes, primarily CYP2C9, to metabolize and break down THC in the bloodstream. Genetic studies show that roughly 1 in 4 people possess a gene variant that makes them slow metabolizers of THC. Because they break down the drug less effectively, slow metabolizers experience much stronger psychoactive effects and a significantly extended chemical half-life from the same dose. These individuals often report severe negative effects during their initial use, such as intense drowsiness, laziness, and difficulty concentrating. However, they may also experience simultaneous rewarding effects, which can drive them to continue using the drug despite the physical discomfort. This genetic difference places slow metabolizers, particularly young females, at a higher biological risk for developing cannabis use disorder. Genetic and microbial variables eventually meet through enterohepatic circulation, the body's internal recycling system. After the liver processes THC, it sends metabolites back to the gut, where specific bacteria can catch those compounds and strip them down. This action recycles the active THC back into the bloodstream, essentially redosing the host from within and prolonging the high. For those already genetically predisposed to slow metabolism, this microbial recycling loop creates a perfect storm of individuality. From your heart to your DNA, the human body acts not as a generic template, but as a deeply customized landscape. The future of medicine, whether preventing heart failure or treating addiction, depends on decoding these radical variables and finally moving past the myth of the average human.